This video is going to explore the formula for the area of a triangle, and we'll be using the vertices of the triangle to find its area. Okay, so before we start, we need to look at the actual formula for the area of a triangle, and this is in your formula log table, so again, you don't need to learn it off, but you do need to learn how to use it and how to label the points going into it. Now, you can only use this formula if one of your vertex or vertices, which is the corners of the triangle, is 0, 0. To use this formula then, you basically need 3 vertices, and vertices are just corners or points on the triangle. One of them must be 0, 0, so the origin. The other one then would be labelled x1, y1 as you normally would, and x2, y2. So let's look at this example here now. So we have x1, y1, x2, y2 and a 0, 0. So we can just put this straight into the formula because one of our vertices is 0, 0. And we know that we can only use this formula when we have a vertex that is 0, 0. So when the point is 0, 0, we basically label the remaining points, so A and B, x1, y1, x2, y2. So let's do that now. We have x1 and y1, and we have x2 and y2. And now we simply substitute that into the area formula. And even though it's in the log tables, it's always a really good idea to write this formula out every time because you will pick up marks. So it's x1 and y2, take away x2 and y1. Now this point here in the formula, these lines, just like they are here, are called absolute value. And for absolute value, you can never have a minus. So if after you fill this, substitute this in and simplified it, you get a minus, you automatically change that answer to a plus because absolute value means that it can never be a minus. So we substitute into our formula, we have a half. Our x1 is 5, so we have 5 times our y2, which is 2, take away x2, which is 2, times y1, which is 3. Okay, so very simply then we have a half of, well, 5 times 2 is 10, take away 3 times 2, which is 6, so that leaves us with a half of 4, and we know that that is 2. Half of 4 is 2, and it is just as simple as that. Okay, so again, just like the last example, we have vertices A, which is 2, 4, B, which is 3, 8, and 0, 0. So because one of our vertices is 0, 0, we can start straight in by labelling the remaining points. So label them x1 and y1, x2 and y2, and then you can go straight into step 2 of filling it into the formula. Now, as before, you always write out the formula, so it's a half of x1, y2, take away x2, y1. And again, that's in your formula and log tables book, so you do not need to learn it off. Okay, so we do basic substitution next. We say a half of, well, x1 is 2 times y2, which is 8, take away x2, which is 3, times y1, which is 4. Okay, so now we multiply them. Well, 8 by 2 is 16. Take away 3 times 4, which is 12. And we're left with, well, half of 16 take away 12 is 4. And again, a half of 4 is 2. So for this example, it's slightly different because none of our vertices are 0, 0. And we can only use this formula when we have 2 vertices and one of them is 0, 0. So you're now going to look into translating points on a plane. Now this sounds far more complicated than it is. What we do is we take a point. Now it can be A, B or C. It won't matter because your end answer is going to be the same, irrelevant of which one you choose. So let's just say, for example, I choose B, okay? I'm going to figure out, well, what do I add or subtract to the x and y values in B to get me 0, 0. So let's try that now. I'm looking to get to 0, 0. If I'm at 7 and I want to get to 0, well, I subtract 7. Because 7 take away 7 is 0. In the same way, if I'm at 2 and I want to get to 0, I subtract 2 because 2 take away 2 is 0. Now what I do is I apply the minus 7 and the minus 2 to the other 2 points. So if I'm applying them, I'm basically doing the same thing the whole way across. So I'm saying, what is 3 take away 7? What is 6 take away 2? What is 4 take away 7? And what is 1 take away 2? And your rules of integers are going to come into play here. So you're going to basically create a new set of points by applying this. So all I did here was 3 minus 7 minus 4, 6 minus 2, 4, 7 minus 7, we know is 0, we've already figured that out. Then 4 minus 7 is minus 3, 1 minus 2 is minus 1. So now you'll see that we have 2 points and one of them is 0, 0. So now we can use this formula. And we go back to our original step 1 of labelling the points x1, y1. So we simply say x1, y1, x2, y2. And we rewrite our formula, which is a half of x1 times y2 minus x2 times y1. And then we substitute that in, so we have a half of, well, x1 is minus 4 and y2 is minus 1. Take away, well, x2 is minus 3 and y1 is 4. Well, when we break that down further, we have a half of, well, minus by minus is a plus, 4 by 1 is 4. Take away, well, minus by a plus is a minus, and then we're minusing minus 12. Okay, so then we're left with, well, 4 minus minus 12 is plus 12, so 4 plus 12 is a half of 16, which we know is 8. And the important thing to remember here is that if you chose this point to find a 0, 0, it will still work out as 8. It doesn't matter which point you choose, I just chose B. And you can only use this formula when you have 0, 0 as one of your vertices. And if, like this example, where neither of the 3 vertices are 0, 0, you simply apply a translation. You see, well, if I was at B and I wanted to get back to 0, 0, what would I do? I would take away 7, I would take away 2. And a bit like algebra, what you do to one term, you must do to all of them. So if I applied that to B, I must apply the exact same to A and the exact same to C. Okay, so let's take another example now of x is minus 1, 3, y is 2, 2, and z is 6 minus 10. So here, none of our vertices are 0, 0, so we must make one of them 0, 0. So we do the exact same thing as the last question. We say, well, what can I apply to x that will get me 0, 0? Okay, well, straight away we know that minus 1 to 0, you're just going to add 1. And 3 to 0, you're going to take away 3. So what you now do is you apply the plus 1 minus 3 to each of the values in the y and the z coordinates. Now again, you could choose to do this with y, map that to 0, 0, or z and map that to 0, 0. All you're doing here in step 1 is translating points on a plane. So remember, what you do to x, you must do to y, you must do to z. So that's what we're going to do now. We're going to see, well, if we apply it, what are our new sets of points for y, and what's our new set of points for z. So I'm adding 1 and I'm taking away 3, I'm adding 1 and I'm taking away 3. Well, straight away 2 plus 1 is going to give me 3, 2 minus 3 is going to give me minus 1, then I'm going to have, well, 6 plus 1 is going to give me 7, and minus 10 minus 3 is going to give me minus 13. Okay, so now that we've done that step, we can move on to step 2, which says label the two other points x1, y1. So the two other points are basically the points that are not 0, 0, so y and z in this case. So we label it x1, y1, x2, y2, and then as normal, we write out our formula, we fill in our formula, and we get the answer for the area. So let's do that now. We have a half of x1, y2, and again, I know it's tedious, but writing out the formula will give you some attempt marks in a question, and it's a very easy 2 or 3 marks. So a half of, well, x1 is 3, y2 is minus 13, take away, well, x2 is 7, and y1 is minus 1. Okay, so we have a half of, well, 3 times minus 13 is minus 39. Take away, well, minus by a minus is plus, so we've plus 7. So that gives us a half of minus 32. And again, I told you at the very start of the video that for absolute value, you can never have a minus in between the two lines. So this automatically becomes a positive 32. So we change that to a plus 32. So we have a half of 32, which we know is 16. And that is your final answer, 16. So remember, if you don't have a vertex which is 0, 0, you must map or translate the point to make a new set of points, and then you can use the formula.